So today I'm going to teach you about the difference of two squares. So the difference of two squares, difference means subtraction, right? Remember the basic words. Plus means the sum means addition, right? Shortcut for summation. The long word is actually summation. So sum is addition, difference is subtraction, product is multiplication, and quotient is actually division. So you must know these words: sum, difference, product, and quotient. So if they say the difference of two squares, it just means we have a square minus another square. So it's two squares subtracting. That's why it's called difference. So this is not called difference of two squares. This is the sum of two squares because this is a square and this is also a square, right? So when they say difference of two squares, it's two perfect squares subtracting, right? So whenever we see difference of two squares, this is how we factorize it. We just open two brackets and we found the square root of the first term, which is 2, right? Square root of 4 is 2. Then the square root of the second term, square root of x squared is just x. So we just do that. Then on one bracket we just put a plus, on the other one we put a minus. So the order doesn't matter as long as you've got a plus on one and a minus on the other, and you're done factorizing. That's the difference of two squares. Let's go to another example. Let's say we have 16 x squared minus 25 y squared. Well, it's the difference of two squares because this is a perfect square and this is also a perfect square, right? So when we factorize it, we're just going to open two brackets and we're going to say the square root of 16x squared, which is actually just 4x, and we have 4x again there, and then the difference of 25y squared just becomes 5y. 5y as well there, and then the one we have a plus, the other one we have a minus. We can even say minus and plus here. The order really doesn't matter. Let's go to the third one. So let's say we have something like 25 x squared y to the power of 4 minus 64 x squared y to the power of or rather, let's just change this. Let's call this a to the power of 4, b to the power of, let's just say, 6. So how do we do this one? Well, you see, as long as an exponent is an even number, if it's an even number of an exponent, then you know it's a perfect square. For example, the square root of 2 to the power of 4 is 2 to the power of 2. You see, you just have to halve the exponents. It's that easy, right? So whenever we've got an even number of an exponent, the square root of that is just half the exponents. For instance, the square root of 2 squared is just 2, right? But notice the exponents are actually being halved, you see. So let's square root that. So let's find the difference of two squares, I mean. So this becomes 5 and 5 as well, and then the square root of x squared is x. The square root of y4 is what? It's just y. The square root, so we just repeat the same thing, and then here we just say the square root of 64, which is 8, and then the square root of 8 to the power of 4 is a squared. The square root of b is actually gonna be b cubed, right? We just have the exponents, and then we write the same thing here: 8a squared b cubed, and then on one we have a plus, on the other we have a minus, and we have factorized it. You can actually try the next one I'm gonna give you. Just post a video and you'll press play after you're done writing to compare your answers. So let's say we have got something like this. Let's say we have got 64 x to the power of 6 y to the power of 12 minus, let's say, 16 z to the power of 18. Let's just say, let's just call it, I didn't write in alphabetical order, or rather let's just say this is gonna be a to the power of 18, and let's just say this is gonna be f to the power of 20. So yeah, you can factorize it. You can pause the video and factorize it, and then from here, if you factorize it, you will have, okay, of course we have to open two brackets. So this is going to become 8, and then this is going to become x cubed. We just have the exponents: y to the power of 1, y to the power of 6, 8x cubed, y to the power of 6. And then now the square root of this stuff is just 4. Then a18 gives you a9, and then f20 just gives you f10. So this is the same thing there. Alright, just due to space, f10. And then on one we have a plus, on the other we have a minus. Alright, here's another one you can try. Let's say we have got something like 1 minus 4x squared. Well, it is really a difference of two squares, this stuff, right? It's really a difference of two squares, because one is actually a square, one is a square, is a cube, is also the power of 5, right? So because the square root of 1 is 1, the cube root of 1 is also 1, so 1 is a square actually, right? So the square root of 1 is 1, square root there. So then the square root of 4x squared, of course we know is 2x. So on one we put a plus, on the other we put a minus. So there we have it, as simple as that. So it's quite easy to factorize it, right? Quite easy to factorize difference of two squares.